Hi, all right. We are now going to talk about isomers. We are on page number 39 of your notes book. And so let me get my pen feature. All right, so this is going to be page number 39 in your notes book. All right, so an isomer is a compound with the same molecular formula but different structures, right? The prefix iso means something's the same but not everything. We've seen the prefix iso when we talked about isotopes, right? Isotopes have the same number of protons, different number of neutrons and mass. So an isomer is the same molecular formula, which means the same number of each element, right? So the same elements and the same number of each elements, but they have different structures. So they're put together differently. And when you put things together differently, they're going to have different physical properties and different chemical properties. Just like enzymes, right, where they're lock and fit and everything has to do with the shape of the molecule, that's going to be the same thing with organic chemistry. The shape of the molecule is going to determine whether or not something is going to be reactivity or the boiling points and melting points and what form it takes, solid, liquid, or gas. All right, so carbons are connected differently. That's called a structural isomer. So if I have a long straight chain and I suddenly give it a branch instead, right? Take one off of the end and make a branch. That's a structural isomer. If the double or triple bond between different carbons is in a different location, that's what we call a geometric isomer. The molecular formula, right, that means the same number of each element, the same number of carbons, hydrogens, oxygens, whatever, is going to be exactly the same in the two isomers. Everything else is different. So the structural isomers have atoms joined together in a different order. So here we have butane and we have 2-methylpropane. These two things are structurally different. We agree. They look different structurally. They're put together differently. But what you will notice is they both follow the same formula, C4H10, which matches our CnH2n plus 2 from table Q, right? So we still have an alkane, right? So we have the ending ANE, right? Which has to do with the fact that these are all single bonds. So what I have here is I have a structural isomer. These are isomers of butane. So butane, but, the prefix but means four carbons connected by single bonds. And so now this is not 4 carbons. This one is 3 in a row. And now I have this right up here, which is what we're going to call a branch, right? So if I kind of think of this like a log or tree, and then I've got this as a branch. So if I took this CH3 and I put it there, that's this molecule. So I have the same building blocks. I just made something different with different physical and chemical properties. So far, we've only learned how to name these straight chains. We haven't learned how to name these yet. So where does this whole number 2, what does that 2 mean? What does this whole methyl mean? And what does all of this mean? So here we have our directions with how to name, right? Don't worry about IUPAC. That just stands for International Union of Physics and Applied Chemistry, just an official naming system. So we're going to name the longest continuous carbon chain. And then that's going to be the first thing we do is we count from each end of the carbon, count every possible direction you can count. You're looking for the longest continuous chain. What does continuous mean? It means if I'm counting, I don't pick up my finger, I don't pick up the pencil. Okay, so we're going to be working from the end of the name. That's called our parent chain, right? That's going to be our parent chain. Okay, so here we have our parent. There's 3 carbons. And so that's called a substituent, which we're going to call a branch. Okay? So here I have 1, 2, 3, 4, 5, 6 carbon chain, 3 carbon chain, 6 carbon chain, and they have branches. So then this would be propane. This would be hexane, but it's not just propane. It's not just hexane. I've got this other stuff sticking on there, so I have to have a way of naming that extra stuff. So we find the longest chain, right? Counting every possible direction. So I can go, hold on, let me do my eraser. So let's do that. And let's go back to, let's go to green. Okay, so 1, 2, 3, 1, 2, 3, 1, 2, 3. I counted every possible direction that I could count. So every possible direction I could count, and the longest chain that I could find was 3. So I'm going to circle my 3. That's where propane comes from. So 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4, 5. And we can go backwards and we can do the whole thing all over again. Okay, so the longest I could count over here was also going to be 6. So then since I had 6, oops, I would need to go back to my pen. So since 6, that's where the hexane comes from. So the second thing we're going to do is now we're going to name the branches, and those are called alkyl groups. Notice how that is YL. So we're going to name our branches with YLs. Our substituents get this YL ending. So just like in a foreign language where you change the ending to give some sort of meaning, like, I don't know, even in the English language, run versus runs, one's plural, one's singular. So we use this YL to mean branch. And that Y looks like a branch and L looks like a tree. So I have a 1 carbon branch is a methyl. So this branch is 1 carbon. So then this branch is a methyl branch. And so now this is not a 3 carbon branch. This is 3 separate. I have 3 1 carbon branches. So then that would be what we would call a trimethyl. It wouldn't be a butyl, and it wouldn't be a propyl, right? This is not a propyl. This is trimethyl. I have this methyl, I have this methyl, and I have this methyl, right? The prefix meth means 1, right? Again, we're using our reference tables, table P. If I have a 2 carbon branch, I call it ethyl because, right, our prefix eth means 2. And a 3 carbon branch would be propyl, and so on. So we're going to choose an end to start counting because we have to give a location for those branches. We have to say where the branch is. And so we want to count using the lowest possible number to identify that that carbon is on. So let's go through and let's name this one. So I'm going to count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. Okay, so 5 is the longest possible chain that I could count. So what I'm going to do is I'm going to circle that 5 carbon chain. So then any carbons outside the chain are a branch. And a branch is going to get a YL ending. How many carbons are in that branch? 1. So then this would be a methyl branch. Okay. So then I'm going to count my longest chain, right? We said that was 5. So then the prefix for 5 is what? You tell me. Do you have table P open? All right. So the prefix for 5 is going to be pent. And then I have single bonds. So ANE. All right. So the parent chain is pentane. So now I have to say, where is that branch located? Is it, why am I calling that carbon number 1? Why am I not calling this carbon number 1? Well, you have to remember, this is a 2-dimensional drawing of what exists in 3 dimensions. So if I take this molecule and I flip it over, then it's the same thing. It's just flipped over. So I am going to count from this side because the branch is closer to this side. So that's why I'm calling that carbon number 1. That's carbon number 2. So then our branch is on carbon number 2. and that's 3, that's 4, and that's 5. So then that's where this 2 comes from. So this is methyl pentane, right? That's methyl pentane. And now this 2 says that's where that 1 carbon branch is located. So when I take this whole name, let me do some erasing. If I take this name, and let's change color to this orange, and I'm going to decode the name. On carbon number 2 is a 1 carbon branch on a 5 carbon chain connected by single bonds. All right, so now let's practice our condensed structural formula. So I have CH3, and now I have a CH2, okay? And now I have another CH2, and now I have a CH, and now this parentheses is telling me that the branch, that means that it's connected here. So then that's this branch, and then now I have a CH3. That's our condensed structural formula. So if there are multiple branches of the same substituent, right, if I have multiple methyls, for example, there needs to be a number and a prefix on the name to represent each of their branches. So let's take a look at this one. So I have CH3, CH2, CH. So here I have a branch and a branch. I have a 1, 2, 3, 4, 5 carbons. So what is that going to be? 5 carbons is pentane. So actually, I want to go backwards. Hold on. I want to come up with the name without you seeing the name first. Oh, wait. Go back. Back. Okay. So I have 1, 2, 3, 4, 5. So then if I have 5, right, that's going to be pent for 5, connected by single bonds, A-N-E. I'm going to circle those 5 carbons. Anything outside the circle, carbon outside the circle, is a branch. I have a branch and a branch. I have 2 separate branches. Just like this is my house, this is my next door neighbor's house. My house and my next door neighbor's house are not combined. It is not one big house. It is not a big long house. I have 2 separate. I have 2 separate chains, 2 separate branches here, and each one has 1 carbon. So I have a methyl, and I have another methyl. So instead of saying methyl, because that would be redundant, I want to combine those 2 methyls. So then methyl, right? So then I'm working from the end of the name forward. So I have the chain, now I have the branch, and I've got 2 of those. So dimethyl. And so now I have to say where exactly each of those methyls are. I need to give a location to each. So it looks like they're closer to this end of the molecule. So I'm going to start and I'm going to call this one carbon number 1. This one's going to be carbon number 2, 3, 4, and 5. So since I have 1 on carbon number 2 and 1 on carbon number 3. So then that's where this 2, 3 comes from. That's 2, 3 dimethylpentane. So when I break this apart and I translate this word, on carbon number 2 is a branch and carbon number 3 is a branch. There's 2 1 carbon branches on this 5 carbon chain connected by single bonds. All right, so if I have 3 of the same, I would use the prefix tri. 4 would be tetra, like Tetris. All right, so now let's look at our condensed structural formula. I'm going to just do a little bit of erasing so it doesn't look so messy up here. Okay. So remember, you have all of these PowerPoints are in your notebook, right? So you don't have to take notes if you don't want to. Okay, so condensed structural formula. Oh, let's give a name in the condensed structural formula. All right, let's count. 1, 2, 3, 4. 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. I believe that it looks like 4 is our longest connected chain of carbons. So let's circle those 4 connected chains of carbons. Any 4 is fine. As long as you're circling the 4 connected carbons, your name is going to be correct. So then now any carbons outside of the circle are branches. So I have a branch here, here, and here. So this branch has 1 carbon, this branch has 1 carbon, this branch has 1 carbon. Are those carbons connected to each other? Nope. They are like houses on the street or branches coming off of a tree. So I have 3 1-carbon branches. So I have 3 1-carbon branches, and then I'm going to start by counting my longest chain. 1, 2, 3, 4. According to table P, the prefix is bute. And now single bonds are connected, so ANE. So now I have 3 1-carbon branches. That's not propyl, because propyl would be 3 carbons connected together. So then I have methyl. I have 3 of those, so trimethyl. So now I have to give a location for each one of those. So since this is the closest end of the molecule, I'm going to start and I'm going to call this one carbon number 1, 2, 3, and 4. So now I have 2 of them on carbon number 2 and 1 of them's on carbon number 3. I have to give a number for every single branch. So it's 2, 2, 3. So you cannot just assume the reader knows that if I said 2, 3 trimethyl, that one of them would be on carbon number 2. You have to give them each a number. So 2, 2, 3 trimethyl butane on carbon number 2 and carbon number 2 and carbon number 3. There's 3 1-carbon branches on a 4-carbon chain connected by single bonds. Condensed structural formula. I don't know if I can, I can move that out of the way. Nice. So I have a CH3, and now I have a C, and then now here's my branches, right? So I have 2 CH3s. Oops, I don't know what I did this there. Oh, interesting. It is now going to be closed captioning what I'm saying. Okay. I'm going to try to figure out how to get rid of that. Or I'm just going to keep going. All right, so let's list. So if I have a different substituents, like let's say I have an ethyl and a methyl, we're going to put those in alphabetical order. So a butyl would come before an ethyl comes before methyl, and these become tongue twisters after a while. So then if I were to do 3-ethyl 2,4-dimethyl decane, that's so tricky. So decane would be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? I'm working from the back of the name forward, connected by single bonds. So I did the decane part. So now on carbon number 2 and carbon number 4, I have 2 1-carbon branches. So on carbon number 2 and then carbon number 4, I have branches. And then on carbon number 3, I have an ethyl. So I have 2 carbon branches. So then every carbon gets 4 bonds around it. And I'm just going to make sure that I have all of those bonds. And at the end of all of those lines are H's. So in making sure commas separate numbers and hyphens separate numbers from words. But don't worry about the proper punctuation. Okay, so then there's never branches on end carbons. Why? Because I'm just going to make a longer chain. Right, so this is an example. So this is 1, 2, 3, 4, 5 connected carbons. So that's the same thing as this, right? That's 5 connected carbons. So what do I call 5 connected carbons? I'm going to call that pentane. Okay, so let's name this compound. and I need to count in every possible direction. So 1, 2, 3, 4. Okay. 1, 2, 3, 4, 5, 6. All right. So far, 6 is my highest number. Every possible direction. 1, 2, 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. Okay, it looks like 6 is my longest connected chain. So what I'm going to do is I'm going to circle the 6 carbons. 1, 2, 3, 4, 5, 6. Here's my 6 carbons connected together. And I have a branch here and I have a branch here. So when I have these 6 carbons connected together, so then that's going to be hex, connected by single bonds, ANE. So now I have 2 1-carbon branches. So then I have a methyl and I have another methyl. So then I have a dimethyl. Terrible handwriting today, isn't it? As always. So let me just give myself a little bit more room here. So I have dimethylhexane. And I need to figure out, and I need to give the numbers as to where exactly on this 6-carbon chain are those 2 1-carbon branches. So I have to figure out this is carbon 1, 2, 3, or 1, 2, 3, 4. So which direction am I going to count to get my shortest possible number to my first branch? So then I'm going to count this way. So then I can call that carbon number 3. Because if I went the other way, then that would be 4. And I need to get the smallest number. So then I have on carbon number 3, and that's not going to be a 4, right? So I have 3, 3, because notice these are both on the same carbon. 3, 3 dimethylhexane. So now let's look at our condensed structural formula. All right, so then let's just do some erasing, right? Because then it's a little bit less messy. And our condensed structural formula, I have a CH3. I have a CH2. Now I have a C. And now here's the branches on that C, right? So I have the CH3, and I have 2 of those. And now I have a CH2. And now I have another CH2. And I have another CH3. And there's our condensed structural formula, right? So then all I did was take that and made it into that. Okay, let's give this one a name. And we're going to write a condensed structural formula. So at the end of all of those lines, those are all hydrogens. So first thing we have to do is we need to count the number of carbons, the longest chain of connected carbons. So 1, 2. Oops, why doesn't this pen? 1, 2. Oops. All right, I'm not sure why it doesn't really want to work. So 1. What is going on with my pen? Okay. 1, 2, 3, 4, 5, 6, 7, 8. All right, so far 8. Let's see if I can count more than 8. Every possible direction. So 1, 2, 3, 1, 2, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oh, I'm going to have to erase. My touchscreen is being very sensitive today, as you can see. All right, so I think that 8 carbons is the longest chain that I can count, right? Or let's just double check. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. All right, so I believe 8 is our longest chain of connected carbons. So I am just going to I want to circle the 8 connected. So I think that was what? 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8. Any carbons outside of the circle are branches. So let's go with a different color for our branches. Let's do some purple. I have a branch, and I have a branch, and I have a branch. I have a 1 carbon branch, a 1 carbon branch, and a 2 carbon branch. Okay. So now I'm going to work from the parent chain backwards. So now the parent chain, right? Those are the carbons in red, right? That was 8. So that's octane, right? Because it's 8 connected by single bonds. So now I have a 2 carbon branch and I have 1 carbon branches, right? So I have, let's go back to purple because I want to use those for the branches. So I have methyl and I have ethyl. So I have to go with the ethyl first. So then, because it's going to go alphabetically. So I've got ethyl comes before methyl. Okay, so there's our long carbon chain. So then, but I am going to count from the shortest direction. So, right, so this is carbon number 2, right, because that's 1, 2. And then that's 3, and that's 4. And so then I have 2,2 dimethyl, 4 ethyl. I probably would not even ask you this, and you probably wouldn't even see that on the Regents exam. Don't even worry about it. So if you can name this one, you could name them all. And there's our condensed structural formula. All right, so let's give these a name. All right, so you should give these a try. And so you should pause the video, and then you can give that a try and see if you can do that first. Okay, and let's see. All righty. I'm just checking in my notes just to see where we are page-wise. Okay. So count the longest chain of carbons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 carbons is the longest chain that I could count. 6 carbons long. All right. So 6 carbons. All right. So 6 carbons means that I have hexane. So 1, 2, 3, 4, 5, 6, right? There's my 6. And so I have a branch, and my branch has 2 carbons. So then that is going to be ethyl, right? Because 2 carbon branch on a 6 carbon chain. This is ethyl hexane, but I have to say where that ethyl is. So is it either going to be 1, 2, 3? Is it on carbon 4 or carbon number 1, 2, 3? 3 is the smallest number, so it's 3 ethyl hexane. Let's look at our next one. 1, 2, 3, 4 carbons. 1, 2, 3, 4 carbons. So 4 carbons is our longest connected chain. So let's just go back here, and I'm going to circle our 4 carbons connected. Well, I could have connected those as a straight line. I'm just going to show you that it doesn't matter whether or not I connect, if I circle them connected in the straight line or if I connected them twisty, the name still comes out to be the same. So I have 1, 2, 3, 4 carbons. So that's butane. And now I have a 1 carbon branch. I don't know where I keep getting this weird line from. So then this is going to be methyl butane. And now I have to say, where is that methyl? Is it on carbon number 1, 2, or 1, 2, 3? It's carbon number 2. So it's 2-methyl. Okay, now we're going to learn how to draw. So I have 4-ethyl 2,3-dimethylheptane. Oh, that's a tongue twister if I ever heard one. So basically, I'm saying on carbon number 4, there is a 2 carbon branch On carbons number 2 and 3, I have 2 1-carbon branches on a 7-carbon chain connected by single bonds. So then 7, 2, 3, 4, 5, 6, 7. All right. On carbon number 4, and since I'm drawing this, I can count whatever direction I want. So then this is 1, 2, 3, 4. I'm going to have a 2-carbon branch. So now on carbon number 2, I have a 1-carbon branch. And then on carbon number 3, I have a 1-carbon branch. So now all I've left to do is make sure that every carbon always has 4 bonds around it. So then this carbon only has 1, so I need 2, 3, 4. And so I know that I need 3 here, right? So those are going to be H's. And then I need 1 more here, and I need 1 more there. So then I need 2 more here, and I need 3 more here. And then 1 there, 2 there, 2 there, and there. And H's at the end of all of those lines. The reason why I didn't do lines around the branches and I just did those as CH3s and CH2s is because otherwise it just gets very difficult to draw. Okay, and then there you have it in your notes. Now we're going to draw and name the 3 isomers of pentane. So I have pentane. So 1, 2, 3, 4, 5. And now I have all of my H's. So there's my first isomer. Right? Pentane itself is still considered part of the isomers. So pent, C5, right? This matches the CnH2n plus 2. So 5 times 2 is 10 plus 2 is 12. So as long as I have 5 carbons in a row, single bonds, 12 hydrogens, or not 5 carbons in a row. As long as I have 5 carbons, 12 hydrogens, and single bonds, it's all good. So what I'm going to do is I am going to take this one off of the end, and I'm going to pluck that off, and I'm going to make it a branch. So instead of having a 5-carbon chain, I now am going to go down to a 4-carbon chain. So now I'm going to go down to a 4-carbon chain. So 1, 2, 3, 4. And now I'm going to take that one and that carbon that I plucked off, and now I'm making that a branch. And so then that's with 3 carbons around it, 3 hydrogens, I'm sorry. And now I'm filling in the rest of the bonds with all of those hydrogens. And I should still have 12 hydrogens, and I should still have 5 carbons. And this is going to have its own name. So this is now 4 carbons in a row. And so it's no longer pentane. So then this is going to be butane. And I'm not sure why my pen keeps doing that really weird line thing. Hold on. All right, let's just try that over again. Okay. So then this is going to be butane. Okay. And on carbon number 1, 2, I have a 1-carbon branch. So I have a 1-carbon branch on carbon number 2. Okay. So then now what I'm going to do is I'm going to take another one off of the end. I can't just stick more on the end. And now I'm going to put that one in another location. So I'm going to go from the 5-carbon chain to a 4-carbon chain, now down to a 3-carbon chain. The best way to do this is just to do this systematically. And